Assalamualaikum and good day to everyone. Now we are going to continue our new topic on force and position vector, which is this is the last topic for chapter 2 part 3. So the objective of the lecture today is to explain what is the position vectors. Number 2, what is the force vector, what is the force vector that directed along a line, and the third one is to explain about what is the dot product. Therefore, at the end of the lecture, students should be able to implement the force and position vectors and dot product in solving problem in mechanic system. Now let's start with the what is the position vector. So now, position vector, it is a fixed vector that locates a point in space relative to another point. And then, the position can be defined by its coordinate in 3D space. And a position vector is directed from A to B. And it is denoted as a position vector RAB. So it means that you need to write. So when we say that position vector, so the how we're going to write is RAB. R is represent the position vector. AB is directed from point A to point B. And then you may refer to this figure. So this figure shows us that R is the position vector RAB. So how to determine the RAB? So this RAB, first we need to get what is the coordinate A and what is the coordinate B. Because here is the 3D. So 3D means that we have the axis X, axis Y and Z. So don't forget our right-handed rule. This is positive Z, positive X has positive Y. So now we need to determine what is the coordinate point A, coordinate point B. So let's say coordinate A is XA, YA, ZA, and then coordinate B is XB, YB, and ZB. So here, in order to get the position A to B, we need to minus B, coordinate B minus A. So we can determine the position vector AB is equal to SB minus XA in I, and then YB minus YA in J, and then plus ZB minus ZA in K. So if the unit in meter, so the position vector unit is in meter. So must remember, if we have 2 points A to B, so here, if you have 2 points here, so if you have 2 points, so B is the ending point and A is the starting point. So we must subtract the tail coordinate from the tip. Understand? Why we need to study the position vector? So what is the application? Now you may refer to this figure 1 and this figure 2. So let's say we need to measure the length of this cable. So the length of this cable. So how to do that? So we can get the position vector R, because we know that how to establish the position vector R. So this is how we can establish the position vector R. We can have 2 points. Let's say we have point E here and point B here, and the position R to B is represented by the position vector R. So you can get the coordinate, then you can have that R is equal to XI plus YJ plus ZK here. And then after we get the position vector, then we can measure the length. How we measure the length? So length can be defined by the magnitude R. So magnitude R, so after you determine the position vector R, then you can have the magnitude R. So how to determine the magnitude R? So as usual, so you can have the square root and also the exponential here. So this is how we can determine the length of the cable. And then next, how we measure the directions of cable AB? So in 3D, direction means that to determine the angles of alpha, beta and gamma. So how to determine the alpha, beta and gamma? So you can use the unit vector. So can you remember the unit vector is represented by the vector divided by its magnitude. So now if you have the position vector of, let's say, RAB, so this unit vector is referred to is equal to position vector AB divided by its magnitude. So this is the application for the position vector. Next is the force vector directed along a line. So what is the meaning of? So this is another application of the position vector. So you may refer to this figure. So let's say we have a force is directed along a line. So like this. So this is the force. So the force is directed in this line. Okay. So this force can represent in Cartesian coordinate. Okay. How to do that? So this force can represent by using the unit vector and the force magnitude. So let's say the first step, we need to establish position vector. So position vector, you can write RAB. So this is the RAB. So here we have point A and point B. Then how to determine the RAB? So you need to get what is the coordinate A. So here you have X, Y, Z here for A. And then also here B, you have the X, Y, and Z. What is the value? Right? Okay. And then step 2, you can establish the unit vector. So what is the unit vector? Unit vector AB. So unit vector can be defined by the position vector of RAB, means that the vector here divided by its magnitude. This is the RAB. So after you establish the unit vector, then step 3, we can get what is the magnitude of force in Cartesian is equal to the force F magnitude multiply with the unit vector AB. So you can resolve the force in Cartesian.